Come on. There we go. Now we're recording. All right, so we are doing a review today. I'm recording the reviews. What will be posted? I should be able to get it up right after class so that you can watch it.
Why is the door still open?
I'll just try to close it.
It feels weird.
It feels good out there.
So yeah, so there's only one.
Go back. You do it.
There's only one graphing problem, so I'm going to do this one pretty quickly. And again, you can go back and watch it again. It'll be recorded if you really are worried. But in this one graphing problem, there are two different methods you have to use. So this is still a system of equations. What that means is you have two equations that make up the problem. When we did Airheads and Honeybuns problem, one of the rules was he spent $15. So that was one equation. One of the rules was he bought 11 items. That was the other equation. So this is just, there's no word problem behind it, but it's a similar situation. There are two rules that we have to meet. And between those two rules, that's what tells us our solution. That's what allows us to find the solution. Where is the solution going to be once we graph these?
Right there.
I don't really like what specific numbers, but just in general. We're going to graph two lines. The solution is going to be... No, you won't know the numbers yet. But when we graph the two lines, the solution will be... Are you answering my question?
X and Y.
Nope, then I need an answer.
X and
I'll
Y.
come back. Not yet. I need an answer. It is where the two lines cross. That's your solution. So, because that's your solution, you need to do a very good job of graphing the two lines. Make sure you draw a straight line. And I'm going to talk about that as we do it, but the best way would just be to have some kind of, I can't pass out rulers. Oh, I could do index cards. That's what I did the other day. Maybe I'll do that. But ideally, if you just have like a debit card or if you have your own little ruler, that would work better. But maybe I'll have some index cards available for people that want them. But if you don't draw a very straight line exactly through the points that you put on the graph, you're not going to get the right answer. And you do have to tell me what the answer is in numbers, like not just circle where they cross. All right, so here we go. Frozen. All right, so in this problem, there are, like I said, two methods for graphing in this one problem. One is the y is all alone method, right? That was the slope intercept. But if you see y is all alone in one of the equations, here's how you graph it. Your first point, you just find the number that's all by itself. That's the y-intercept. Remember. So from there, and I'm probably going to have to scroll off the screen in a second, so hopefully you wrote the problem down on your graph paper. If my y-intercept is -1, I just put a point on -1. There. I got some points already on graph. And I really don't want to have to yell over people during the review because I'm already doing a lot of talking, which I know it's boring for me to sit up here, but it's the only way I can get through every single type of problem. It'll all be recorded, that way you can watch it later. All right, so now I need a second point. That's only one point. I need to know where's my next point. So again, when y is all alone, here's how we find the next point. We use the other number in the equation, which is the slope. So this is the y-intercept. This is the slope. The x is not part of the slope, only the number. All right. Well, if I know my slope is -2, I also know, and if you don't remember this, write it down. And make sure you can get to your notes for Thursday. So if you're, most of this you've got, but you may just want to rewrite everything so it's all in one place. Or if you're going back and trying to find stuff today, make sure you mark it for Thursday, because everything I do today is directly related to the quiz. Don't just trust that you have it in there somewhere, because then one, you're not going to know where to find it when you come to quiz time on Thursday, and two, it may not actually be in there. I need a rise and a run number. So what's the problem?
You don't have one.
I don't have a run number. I got a rise number. That's the -2.
Negative what?
It'll just be 0, right?
Not 0. Nope. We can't just make it 0. What do? I need to change this to a fraction by putting it over 1. I can make any number into a fraction by putting it over 1. Positive 1. Now the 2 stays negative, and it stays on top. Now I have a rise and a run number. Oh, do not just do this, by the way. Oh, I got a -2 in the equation, so I must put a dot on the -2 over here. That could not be more wrong. And yet I've got probably 5 to 10 kids that do it in every class. I don't mean like total, I mean in every class, 5 to 10 kids that will do that. Just go from the -1 straight to the -2. That is completely wrong. We need to use the run and the rise to count over and up or down. So again, if it's a positive run, I'm going to count 1, that's what my run is, a 1 to the right, because again, positive run means go to the right. So I count 1 to the right. Now my my rise number is negative. What does that mean I got to do? It's a negative rise number. I think a couple of you are saying you're signing it. A rise number is up and down. Don't ever go left and right to your rise. Rise, just like an elevator. Elevators go up and down. So if my rise is negative, I have to go down. So that's my second point. My run number was 1, so I went to the right 1. My rise number was -2, so I went down 2. That gave me that second point. I'm going to erase those. So again, I counted though. I counted right, and then I counted down. So you need to draw a very straight line. Here, this will help you if you don't wind up having something straight to use. You could just continue this pattern. Like my pattern is right 1, down 2. Or I could say left 1 and up 2, because remember I could always flip the sign and make it +2 over -1, which would be left 1 up 2. Left 1 up 2, left 1 up 2. Now that kind of helps me draw a pretty straight line. So there. That's my first line. I use the slope and the y-intercept. Second type of problem, though, I do not have y all by itself. Some people still do this. I'm going to say it. Either you use rise over run or you don't. So if I don't have y by itself, which I don't here, I'm not going to do anything with rise over run. That does not come into play at all. I only use that when the y is all by itself and I'm graphing. So in this second one, rise over run is never going to come into play. I'm not going to do anything with that. I'm not going to do anything with the y-intercept. This is cover up and solve. This is the second method we learned. So I'm just going to cover up one term and solve for whatever I see still. So I cover up that term and I solve exactly what I see right there. Well, to solve that, I divide, and you'll always do this. You'll divide by whatever's in front of the variable. Don't forget the negative, though. So if I divide that out, the 3's go away. They just become 1. -3 divided by -3 is just 1. So I get y equals -6. So now, once you solve and you get y equals -6, then you go to the graph. It's y, so you stay on the y-axis, and you just put a point on -6 on the y-axis. I do not do rise and run from here. Again, that doesn't come into play at all on this type of an equation. Y is not by itself, so I can't do rise and run. I have to do cover up and solve again, only now I cover up and solve for the other term. I cover up the other term, and then now I'm solving for x instead of y. So again, I'll divide by the number that's right in front of the variable. And I guess I'll just use blue again. Divide by 9, divide by 9. And I get x equals 2. So So now that I've solved and come up with a number for the variable, I go back to the graph. Now I go to the x-axis though, because I just solved for x. So I go to the x-axis, which is the left and right axis, horizontal axis. And I put a number on +2. That's my second point. Never use rise and run in this type of problem. So I come all the way down, I just connect the 2 points. Oh, kind of got crooked at the top, but that's not gonna matter. Oh, actually, I kind of got off way down here. So now, where they cross is my solution, because that's the point, that's the x and the y that solve both equations, basically. It solves this one, because it's on that line. It also solves this equation, because it's also on that line. It's on both lines. But you need to be able to tell me, not just say, oh yeah, where they cross is the answer. You need to be able to tell me what the answer is. So what's the answer? Don't worry about that. What's the answer? So I got a -3 and 1. How would you write that though? You could say x equals this, y equals this. What's another way to write it? You could make it an ordered pair, like something, comma, something. So what would our answer be?
Comma, negative, well, how I say it, parentheses, 1, comma, -3.
So that's one way to write it. Now, if you're not sure which one goes first, it will be wrong. That's why I'm spending a little time on this, because too many people are thinking that the x is -3 and the y is 1. That is not the correct answer. So whichever way is easier for you to tell or write the answer for me, I'll accept both. But you need to tell me the correct number with the correct variable in some way. And the way we figure it out, if you're not sure how we're figuring it out, remember, run. When I went to visit this graph, I went left and right first. So you find your left and right number first, and we're finding it for this point right here. Well, my left and right number would be wherever I kind of start going down to get to the point, up or down to get to the point. So if I'm going left or right, where do I have to be? Oh, I got to be right there on 1. Then I can go down to get to -3. So my left and right number is 1. Then I go down to -3. So that's how you find out the x and the y. So there's only one graphing problem, but you do have to do both methods for graphing. Oh, wait. Let's do the word problems now. We'll do them first, then we'll come back to do some of the other type of problems. So there are 6 word problems. Some you have to create equations for all of them. Some you have to solve, some you don't. Some you have to define variables. Actually, really, I think just one you have to define the variables. That's it. Mainly, you have to create the equations. So I'm going to tell you, here's the process I want you to go through to create equations. Your first question: are there starting numbers in this problem? That's your first question. Are there... And normally, I would say, is there a starting number? Or is there 1 or 2 starting numbers? But I'll just tell you right now, every equation is a system of equations. So there's going to be 2 equations for everyone. So you're always going to have 2 equations. When you go to write the equations, there's always going to be 2 equations. You're what? You can come in and hang out. Did anybody see a pencil case somewhere over there? I didn't see any pink laying around. Check your last class. Before not just yet. Let me go over the first word problem, and then you can go, because they're all pretty similar. All right, so are there starting numbers in this? Is there a number that's like a starting number? I got a yes. Does everybody think yes? Does anybody think no? Are there starting numbers in this problem? Like, do we have an initial number that we're going to start with, and then we're going to kind of like add or maybe even subtract from it, but mainly add to it.
Yeah.
I would say absolutely they're starting numbers. First hint is one-time fee is kind of the same thing as starting number. So here's your hints on starting numbers. If there's, first of all, if it says initial fee, if it says starting fee, one-time fee, those are the main thing, initial fee or one-time fee. But you're looking for a number that, hey, before any time starts to pass, or if it's not about, I mean, it's still kind of about time in a way. Like, let's take an example of the number of downloads. Before I download any songs, is there a number that I'm already starting with, like an amount of money in the case of downloads?
Yes.
Well, in this one, this is about downloads. So before I download any songs, I've got to pay, depending on which service, either $10 or $3 before I download any song. That's a starting number. Like that's your, if we were going to say if x equals 0, we would still pay that $10 before we downloaded any song. So yeah, they're absolutely starting numbers. How many of them are there? One for each service. So there's two. Again, if I was making you figure out how many equations are right, that would tell you you needed two equations. If there are two starting numbers, you need two equations. But I'm just telling you, every word problem is going to have two equations. So make sure you make that note as well. Every word problem will have two equations when you do the quiz. So now, we'll identify these later. My next question, and this, really the way you should ask this is you should be thinking the answer is going to be yes to this. If you know there are starting numbers, if you've already said yes to that, you really should be thinking that this is going to be a yes answer. So you're going to try to convince yourself almost that this is a yes and figure out how you could make this true, sort of. Are there totals? Known or unknown? We may not know them yet, but is there some kind of a total number that we either are given or that we're looking to find out? I see one person nodding. Marian, what do you think? What would the totals be? And again, maybe known or unknown, so you may not be giving me a number.
It's unknown.
No.
What is it? What is the unknown then? What is the unknown total? Like what's it representing?
2.
Total what then?
Yes.
How many is she down?
I said a Marian.
You said yes.
Total what? No, we're not looking for the total downloads. Not really. That's not the total number. That's a number of downloads, but it's not a total number. It's not the end all be all. That's going to help us tell something else. The number of downloads is going to help us find the total of something. So what total are we looking for? What is the total going, or the total number of downloads going to help us find what total? What's the problem about? So what's the total we're looking for then? It's about yeah, what total are we looking for? 3. Total she what?
Yeah.
So it's about the total month. You're saying monthly cost, but it's about the total she spent. That's what the total is in this. But do we know the total she spent? Did they give us that number? Okay, so here's the next thing you write. Well, first, the next thing you write is, are there totals? If you answer yes to both of these, and again, once you answer yes to this first question, you're kind of thinking, yeah, there should be totals. So would it make sense that there's totals? Well, yeah, she's spending a total amount of money that's made up of the starting amount and then the amount that she is based on how much she downloaded. So once you answer yes to these, so yes in this case, here's the next thing it's not really a question that you ask. I'm just going to write it here and then erase it, so make sure you write it down with me. So if the totals are unknown, so we know that there are totals, And there's pretty much, by the way, always going to be totals. There's almost never a time when you say, no, there's no totals. I'll just tell you that one. There's pretty much always totals.
Oh,
There's pretty much always totals. It's just a question, do we know what they are, or are they unknown? So, if the totals are unknown, that tells you, one, we're using this format for the equations. That's the first thing it tells you. That format.
So what if the totals are known? What format?
We'll get to that later. The second thing it tells you is this. Y is going to be the totals. We need a variable because, again, the totals are unknown. That's when we use variables. It's for unknown information. And Y will always be the variable we use. We would never use X for the totals. Because remember, Y is all by itself in this equation, which makes sense to put a total all by itself. Because the other two pieces added together will be that total. So if the totals are unknown, this is your next step right here. So first two questions you ask, and then you say, well, if they're unknown, that's what I need to do for my equation. From there, hopefully you can do it pretty easily. I'm going to erase that bottom part, so that's your last chance to write it. Looks like everybody's done writing.
Let's talk about.
If you haven't finished, then I got to erase it, so you can go back and watch the video. I record it for that reason, especially on a review day. All right, so now we know the format of the equations. Y equals mx plus b. We know the total is going to be y, because I just said if they're unknown, y is going to be the total. So now, what's the next thing that we said the other day that'll help us with this? Before we even really worry about which numbers and where we put them. We're kind of worried about that. I gave you another hint. I gave you another hint. So, and I'm going to say red is about Spotify, green is about iTunes. Gave you another hint for the next step of an equation. You need to make sure this matches up.
Yes.
Or these match up. An easy way to get some points. So let's write everything down.
So let's see.
Everything important. Everything important. This was important. I emphasize this. I'm sure you wrote it down. This is what I mean by notes, so you can't go back and find stuff. You don't highlight stuff.
I was gonna talk about that when that, I forgot what day it was.
What numbers are about Spotify?
Yeah.
So here's your next thing you need to write down. If you don't remember this or can't find it, the numbers that are like related to the same thing better be in the same equation. So the total for Spotify and the numbers that deal with Spotify better all be in the Spotify equation. I shouldn't see a 10 in one equation and a 15 cents in the other equation, because they're about the same thing. So we know they've got to be in the same equation. So here's how we create the equations then. What is my starting number for Spotify? 10, right? That's before I download anything, I've got to pay that $10.
Oh.
To that, I'm going to add some money. What's the money that I add? It's going to be based on how much I download, which is the download cost. And frankly, it's the only other number, right, in the word problem that's about Spotify. So again, I should not see the 0.45 there, since 0.45 is not about Spotify. It wouldn't go with the 10.
Yes.
Now, here's the next question. What am I missing in that red equation?
Yes.
What am I missing?
Oh, 0.5.
No, I got the total, that's why.
Variable?
I don't have an X, right? I need an X. Gotta have an X. Where is that X gonna go?
10.
How do you know it goes with 15?
No. 10.
No, it goes.
10. It goes with 10 because of the formula. It goes with 10 because of the formula.
No, it goes.
Because the formula is next to the y.
Doesn't matter though. Yes, you're right. This is the formula. Doesn't matter, doesn't mean I can't say, well, this is also the formula. I can be the, I can switch the order of those if I want. You can't always say B is going to be at the end every single time. So here's the 2 ways to know. 3 ways. I'm going to give you a 3rd way, actually, that I've added. We're downloading songs. Every time we download a song, we need to pay more money. So we're multiplying those 2 things together. And X is an unknown. X is the number of downloads. We didn't talk about what X is. So X is the unknown number of downloads. So the amount of money we pay per download times the number of downloads, which is the unknown X, that's how we're solving or setting up the equation. So that's more of the math way that you need to understand. Here's the cheat sheet version. Don't ever put X with the startup. X will never, ever, 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 ever go with the startup number. Because the startup number is the B value in the equation. X isn't with B, it's with the rate of change or with the slope number. So never put X with the startup number. I didn't see many people write that down, so I'm going to assume nobody's going to miss that on the quiz. And if you do, boy oh boy, I'm not going to be kind on the rest of the grading. When I give you stuff to write down and you miss it on quizzes, it makes it really tough to give you partial credit on the other stuff, because I'm like, oh, they clearly don't pay attention. Why should I help them out if they're not paying attention in class, writing down what I told them to write down? So again, don't ever put X with the startup number, and 10 is pretty clearly the startup number in this. Oh, and then the 3rd way. Those words back there, I told you, they mean rate of change, right? Like per, every, each.
Yeah.
When it comes to math, and again, this is not all the time 100% guaranteed, but for my quizzes, it kind of is, they also mean multiply. So if I'm saying 0.15 cents per download, well, that means 0.15 times, and then again, the download is represented by the variable X, the number of downloads. So it'd be 1.5, or I'm sorry, 0.15 times X. Per, we could say 0.515 cents each download, every download. Those words also sort of mean multiply. So that's another way to tell where you would put the X is, where is that word per, that word every, that word each. I spent a lot of time on that one. I'm not going to spend much time on the rest of them, even in the next word problems, because they're all the same exact thing. You know that there's going to be an unknown total, so that means that's going to be Y all by itself. You know you've got a startup number. To the startup number, you're going to add basically the only other number in the equation, but it's really your rate of change. And then you always multiply the X times the rate of change, never times the startup. Every single equation that is in this format is going to be just like that. So what's the equation then, real quick, for iTunes? Y equals what? 3 is my startup number. I'm going to pay 3 before I even start downloading. I'm going to add to that 45 cents per, which means times the number of downloads, which is what X represents, the number of downloads. You do have to define the variables, I think, in one problem. Other than that, I tell you how to define them. So that's it. That's your equation. I'm not solving anything out today. I'm more concerned about creating the equations, and I think there's 3 that you do have to solve out, but you can solve them any way you want. It's going to be a long quiz, by the way. You're going to start immediately. Like, we're not going to do bell work. This is your review. This is it. You're going to probably spend the entire class, like an hour and a half on this quiz, because I want to make sure you have plenty of time. I don't even know how many questions total. It's a lot. It's a lot.
31.
No, not that many, I don't think.
A lot of questions.
20-ish, probably. But again, some of them take quite a bit of thought. So, no, you'll still finish in like 10 minutes. That's the way you roll. But I'm not saying that's a good thing that you finish in 10 minutes. All right, so next question, or next equation, next word problem. All right, here we go. What's the first question we ask?
Are there starting numbers?
Are there starting numbers in this? Is there some number we have before we start tracking anything? Yeah, absolutely. In their bank account, right? Before we start adding money to that every week, there's already money in there. There's a starting number in there. So absolutely, we have starting numbers. That one and that one. Those are starting numbers. Before a week has gone by, they've got that much in their account. That's their starting number. So at time 0 again. A lot of times this is based on like a time 0 and then a time 1, 2, 3, 4, 5. It might be weeks, it might be seconds. All right, so yes, we have a starting number. So already we're thinking y equals mx plus b. If you say yes to that question, you're thinking y equals mx plus b. So what's the next question?
Yes.
And we want to again think, yeah, there should kind of be totals if I have a starting number. You're cracking up. So we want to try to think, yeah, there's probably going to be totals. So does that make sense? What's the total going to be though? What is the total?
Unknown.
It's unknown, but what is it? What would what's the total that's we're looking for? Total of what?
Amount saved per week.
No, we know what it's saving per week. That's not unknown.
How much you'll pay?
We know how much we're saving per week. It's not a total
How
of
would
saving
be
per
the
week.
bank when they have the same amount saved?
The total in their account would be the
Last
total.
sentence.
You're right.
He's going.
The total in their account. So again, we're still looking for a total. Still total money, like the last one was total money also. So this one's still total money, it's just the total in their account. So yes, we've pretty much confirmed it's going to be, again, y equals mx plus b. So do we know the totals?
No.
So what does that mean?
No.
But that means y is going to be the total. If we don't know it, and we know it's y equals mx plus b, then y is going to represent the totals. Who am I going to ask for questions? Ever. So let's see, because I'm getting a lot of answers from this side of the room and not as many from this side. We just said that there are totals in this, but we don't know the totals. We also said there's starting numbers in this. What does that tell us? Those two things together, what does that tell us?
Not why.
What does that tell us? Then I need your head up. You've been taking notes. I've given a lot of stuff away.
Can you repeat the question?
I will, and I want you to answer it now, Jose.
Okay.
So I know there's a starting number in these, two starting numbers.
Yes.
I also know I have unknown totals.
Yes.
What does that tell me about this problem when it comes to creating equations?
We have to use a different formula.
You gotta explain what that means.
Why?
Okay, so you need to say, if you're saying yes to these, that means
No.
use this formula. Y equals mx plus b.
We have to use
So
a different.
just writing it down.
We have to use a different formula. The
Can
last
you just
one-
say it?
What formula?
I don't remember. No, is it the one where it's like where you add and you have like one equation up there and one equation at the bottom, and you have to cross, do addition, cross.
I don't think so. It's possible you're just not sure exactly how to explain it. So let me go over it again. I've answered yes to two questions. Well, three, sort of. I said, are there starting numbers? Yes. Are there totals? Yes. Are the totals unknown? Yes. Answered yes to all of those. Here's what that tells me. First, it tells me, okay, I need this format. Basically, as soon as I said, are there starting numbers, and I said yes to that, I'm pretty much already convinced I'm going to use that. Then when I said, are there unknown totals, then I said, yeah, definitely going to use that now. Unknown totals means y is going to stand for the total. So that's what unknown totals also tells me. Again, that's something you need to write down, Everett. I did not see that in your notes. You guys are just not writing much down. I'm not saying everybody, but a lot of you. A lot of, well, you're answering the question. That's fine. So now I just have to figure out, I already know y is going to go over here and it's going to be the total. I know there's going to be two equations in that format. I'm not even going to change colors of pens this time. What's my starting number for?
No, can I get a paper towel?
Just come on and grab one up here real quick while I'm doing this. What's my starting number for Julian? We'll start with Julian. before any time passes, he's got $120 in his account. What's he gonna do to that $120 as time passes? He's going to add to that $20 per, which we said per means multiply, and then what's going to be multiplied times 20? Only thing we're missing, which is x.
Okay.
All right, again, this is your review, so if you're
I
comfortable
know,
with
but
it,
I already knew.
I know.
The last time.
I said if you're comfortable with it, I'm not holding people to them. Well, after I've done the first problem, I'm not holding. All right, so the only thing we're missing is x, but also it makes sense that if he's saving $20 per week, we need to multiply 20 times the number of weeks, which is what x stands for. So x would stand for the how many weeks, by the way. I haven't been writing what x stands for, but most of the time, x is going to be how many of something. Every once in a while, it will be how much, like one of them costs. Like if you're talking about, sometimes when you go in and buy stuff, or sometimes when you buy stuff, they'll tell you how many they buy, so you have to know how much does one of them cost. But it's almost always one of those two things, either how many of something or how much is one of them. Next equation, same exact format again. And I could just write 20x there. I didn't need the times, but since it had the word per, I just put times, multiply. So he starts with 10, right? What's he going to add to it? He's adding 25 per, and then how many weeks, which is x. You'll see these get pretty repetitive when you've already identified that it's y equals mx plus b. And again, I gave you the two questions you need to answer in order to identify that that's the type of equation. All right. Any questions on that? I'm not solving any of these out. We may come back and solve them, but I want to make sure we get through every type of question first. Then we'll maybe come back and repeat some. Yeah, if you're not asking questions, there's not much I can do if you're not getting this. Not on a review day. I got to go pretty fast. All right. Oh, no, I didn't want to do that. All right. So, what's the first question I asked? Actually, hold on. Don't answer that. Anaya, what's the first question I asked? Whenever we have a word problem, we're about to create an equation. I said there's a first question. That's the second question. Before you say, are there totals, there's a question before that. You did not write this down? Aaron, what's the first question you asked? Other Aaron. Sorry, no. Other Aaron.
Oh, me?
Yep.
Herb. Call me Herb.
Herb.
Yes.
You're later.
This question?
Any word problem. If you see a word problem and I ask you to write equations for it, first question you ask yourself is what?
How will I write it?
No. Write down, pay attention. What's the first question?
I've said it like
I've heard
I know
you.
you heard me.
I did. But I'm calling on individuals to make sure they're understanding.
Yes,
Did you want to answer it? Whoa. You ask yourself, are there starting numbers in this?
No. No, yes.
This one better be a pretty easy one to answer because I literally call it a head start. Like it's literally a head start. So yes, now his starting number is 0. We can have 0, Aaron, you need to be listening to me, not having a conversation because you just couldn't answer the easiest question I've asked all day long. So his starting number is 0. That's where he starts. That's fine. You can have 0 as a starting number. It's still a starting number. Doesn't have to be a positive number greater than 0. Now mine's 20, so mine is greater than 0. But just remember that starting number could still be, just like a total could be unknown, a starting number could be 0. So yes, absolutely. So now, as soon as I answer yes to that, what does that make me think? Jose, I'm going to have you try that one again. What is that? As soon as I answer yes to the first question, what am I already kind of thinking as far as creating the equation here?
You're thinking y equals mx.
It would. I'm thinking already. it should hopefully be, or probably be, y equals mx plus b format.
Yes.
Now, my next question to confirm that, Christian Lowe, wake up, bud. Next question, what is my next question right now? Myself. Wake up, bud, you're missing review. Are there totals? Are there totals that either are unknown or known totals? Either way, I'm sorry. In this case, yes, since you answered that, you can. Wait, yeah. So in this case, there are totals. Can't keep waking people up. Yes, there are totals and they're unknown totals. So what does it mean when I have unknown totals? What else does that tell me? In addition to the y equals mx plus b, that's fine. You can answer it. Y is going to stand for the total if it's unknown. So I know the format is y equals mx plus b. I know y is going to stand for the total. What is the total? Total what? Jasmine, total what? Y is going to be the total, but total of what? Because this one's not about money. The other one's about money. It's pretty easy to meet total money. This one's not about money. It's total what?
Total yards per second.
You guys really don't know your names today. All right, yes, it's going to be the total distance or total yards. So we're still doing totals, but just because the problem is not about money doesn't mean there's not a totals. All right, so if we know it's y equals mx plus b, we know y is the total, then we know our format's going to be, what's the starting number? Starting number for me, we'll say. 20. What am I adding? So I'm at 20 yards. What am I adding to my 20 yards? I'm adding 6 yards and then 6 yards per, which means multiply. What's next? And what's that stand for?
How many yards you gain?
6 yards times what? What would we multiply the 6 yards per? That's literally 6 yards per second. You didn't say that the first time. Not the first time you did.
No, he said 3 seconds. That wrong.
Well, you said something else before that. Yards or something. So yeah, again, it's right in the word problem. Like it literally says 6 yards. If per means multiply, then that's times and then seconds. 6 yards times seconds, and x would stand for seconds. So next equation is what for Kentrez?
0.
Yeah, he starts at 0, which again we said is fine, and he adds 8 yards per, and then again he's adding 8 yards per second. So that will also tell you what x stands for if I ask you to define. If you can create the equation first, knowing that y is going to be the total, if you say 6 yards per second here, that tells you x has got to stand for seconds then. So sometimes you can create the equation first and come back and define the variable later if it's a piece. So that's 3 problems right there where you have the same type of format for your equation. So y equals mx plus b format.
Where'd you get 20?
That's my head start, my starting number. This is my equation that's interesting. In the problem right there. It's in the second part, yeah. All right, let's go to more word problems from older. Yes. Yes. All right, here we go, right here. You can go ahead, whoever was going. I think that's got to be one. So now, do we have a start? What's the first question we have? Is there a starting number? Maximus goes in the store and buys airheads and honey buns. What's the starting number?
15.
Oh,
He doesn't start with $15.
Yes.
He doesn't start with $15 in this. Because we're talking about the amount he spent.
Well, you
I know.
Actually,
No, yeah. $1,
I know.
$2.
That's not starting numbers. That's per. Remember, we don't multiply those numbers. Those will be multiplied something.
2.
No.
is it
A
unknown?
starting number means,
No number.
again, a starting number would be before anything happens, is there a number that I'm already, like, is there a number I've already spent in this case? It's about spending money.
No, there is.
No, before I walk into that store, I haven't spent any money yet. The total I spend is gonna be 15. That's a total amount. So if you're having trouble figuring out if there's not an obvious starting number, you need to ask yourself, is this number, which is clearly gotta be the only no, like 1 and 2, I hope you understand 1 and 2 cannot be a starting number. Because you're gonna wind up multiplying those times the number of airheads and number of honey buns. And remember, we don't ever multiply a starting number times a variable. So it's gotta be the 15 that is the only question. Does it make more sense that the 15 is a total amount or a starting amount? Well, hopefully you understand it's more of a total amount. Because that's the total I spend. It's not the starting amount I spend. I'm not adding more money to 15. Like, am I going to add more to 15? No, I'm not. That's the total I spend, right? Like, I'm not, once I spend it, I'm done. That's my ending amount, not my starting amount. I end by spending $15. I don't start by spending, I end by spending. So maybe you can say your total is your final amount or your ending amount if you're confused. So in this case, there is no starting amount. I don't even know how you would apply a starting amount to walking into a store and buying something. I mean, I can't think of it. So yeah, there's no starting amount in this. Oh, there's another part of this equation. I added this later, but I'm going to add it now. Again, so here's another number. So you'd also ask yourself, well, let me see. Is 11 a starting amount?
Yeah.
So he's going to add more to 11. What's he going to add to 11 in this problem? He's already done. He bought 11. What's he going to add to it?
Nothing.
Then it ain't a starting amount if we're not adding anything to it. It's an ending amount. You need to ask, so here's the question to ask yourself, and I'm glad this came up in this class because it didn't come up in other classes. It's either a starting amount or an ending amount, or a rate. Well, a 15 and 11, I hope you know, are definitely not rates. They're not per. There's nothing that says per something. Like a rate, $1, airheads are $1 each. That's a rate, $1 each. Honey buns are $2 each. Those are rates. So a number is either a starting amount, an ending amount, or a rate. And an ending amount would be like a total. So is 11 and 15 a starting amount or an ending amount? Ending amount. So ending amount is a total. Maybe you need to add that in your notes. So a final or ending amount is a total. I mean, the totals are easy to see sometimes, but maybe not as easy in problems like this. Final or ending amount is a total. Because remember, you're adding to a starting number. That's why I call it starting number, because you're going to add more stuff to it. We added distance to it. Sometimes we add money to it. In this case, we're not adding anything else on top of the 15. That's what I ended spending. Same way here. We're not buying more after the 11. We're done buying. All right, so maybe that'll hopefully clarify. So here's the next question then. Did we have a starting amount? Same question, really. Do we have a totals? Total amounts?
Yeah.
We had a starting amount when we had an ending amount.
Something.
We don't have a starting amount.
We have how much we spent.
So how much he spent total, right? He walked in and this is how much he spent.
Okay, so yeah.
That's a total. I walk in, I spent a total of $15.
So I guess
And just ask yourself, does it make sense to put total in front of that word?
Yeah.
Yes.
Or total in front of dollars, I should say. Did I spend 15 total dollars? Does that make
Well, we're
sense?
trying to figure out.
Yeah, absolutely. Then that is a total amount. Did I buy 11 total items? Oh, I erased this.
We're trying to figure out how much money he has.
What does that mean?
No, we're not trying to figure out how much money he has. Not at all.
You stop.
So again, here, let me write this, or let me say this again, because this is confusing, And I know some people are really confused, the ones that aren't saying anything. So here's another clarifying question about what the total number is. Is it an ending amount? Like, are you done with that amount? If you say, yeah, that's my ending amount, then it is a total. Next, if you can say he buys 11 total items, then that number is a total. If he spends 15 total dollars, then that number is a total. And we can say that in this, right? That makes sense for us to say that. Like in the other problem, it wouldn't be when we had a starting amount of 10, we wouldn't say he spends 10 total dollars. Well, no, that's not how much he spends total. That was just part of what he's going to spend. They're going to download. Wait, was that about downloads?
3.
Well, actually, that was in 2 problems, wasn't it? It was in the saving money problem. So that's not the total he saved. It's also not the total that she spent on the download service. So try to add that word total in after the number and see if it makes sense in the problem. If it does, then that number is a total amount. So 11 and 15 are total amounts. Yes, we have totals. What's true about the totals in this problem versus the other problem? How is it different in this problem?
They have to equal $15.
So how is it different in this problem than the other one? There was something really important about the totals in the other problems, we said, that told us something.
The total.
Oh, on the right track when they weren't X. They were Y. Why were they Y? Well, why do we use Y?
Unknown.
I just said.
Say it again.
It was an unknown.
It is an unknown total in the others. Is it unknown in this? Really? Our totals are unknown?
We just said there was a total.
We literally just said those two numbers are totals. So here's, boy, I'm getting more and more worried about this test every second that goes by. Wow. Isn't that, I'll tell you right now, I normally say how easy it is. This is a hard test. It's a hard test on Thursday. So you might want to go back and study some. Don't rely on your notes on this one. I'm telling you right now, don't rely on your notes. No, the test is on Thursday. So, anyway, I'd put a little extra time in if I were you guys for this one. Especially considering it's also the biggest test of the quarter. So, here's your next thing you write.
You know this quarter ends?
We're a little over halfway.
How are we gonna fit quarter 3 and 4?
Somebody was up next. I don't remember who it was.
What the heck?
I did it.
If the totals are known, so now we're dealing with totals that we know. We know the numbers. So we know what the total amounts are. He spent $15. That's a total. He bought 11 items. That is a total. We know the numbers. This is your format. AX plus BY. So X and Y are always just going to be variables in there. We're not replacing those with numbers because that would be solving. We're not solving. We're creating equations. So we're just going to replace the A, the B, and the C. What would C be in the problem? Like what's
The total?
it's the totals where we're gonna have two equations, so it'll be one number in one equation, but it'll be the totals. So you could just do this. I'm gonna erase that, so write it down real quick. If the totals are known, then it's the format is AX plus BY equals C. So I'm about to erase that. So you got 5 seconds. 5, 4, 3, 2, 1, 0. You guys got to keep up on review day. Otherwise, you guys go back and watch the videos.
What happened?
I'd rather watch.
Like,
All right. So, if we know that's the format, and we know the total numbers, right? They're in the problem this time. Where would the totals go?
Better say C.
Yeah. Well, doesn't it make sense? Because Y was the total, and it was all by itself on one side. Like, it was on the left, but it was still all by itself. It would make sense that the number that's all by itself is going to be the total. So yeah, it would be at the end of the equation all by itself. And we have two of them, right? We have a total amount of money and then a total number of items. So just to get some points, you can do that. You don't write anything else, that gets you some points.
Really?
Sure. You got the total right, that's where it goes. You got the C.
So I got on test.
Wow, you're being very nice on this side.
This is the same way I grade every single test. I graded every single test like that. It's just most people didn't try. They didn't write anything down at all. They just- What's that? I just said you get points on
So I can just write that, that's
I
it?
literally said that.
Just write that.
I mean, I didn't say you're getting a lot of points, but you can get some point. Yeah, it's partial credit. I grade every test. This is not different. Same way I grade every test. Just like I said, a lot of times people don't write anything down. They just
Oh
skip
my
it.
god,
Leave
I
it blank.
got money.
So now, I already told you this too. We know we have the variables in there, right? I even told you this on the test when we did this. I said you could just write that in and get points. The X and the Y. Because they're going to be in there. We got to have variables in an equation. Now we just got to figure out what numbers go with what. Shouldn't be that hard. What numbers would go with the 11? What's the 11 about? It's about how many items, right? What numbers are about how many items?
What?
Honey buns and,
Why?
What's the number though about how many honey buns and how many?
it's just $1.
$2.
That's not how many though.
1 and 2?
That's money. I'm not talking about money.
No number.
Nope, that's about money.
No number.
What?
No number.
11,
No.
10.
11 is about how many? 11 is about how many? What other numbers are about how many?
Stupid. 12.
Wait, no.
Dollar thing.
Wait.
Nope,
wait,
that's
wait.
money. You're getting caught up on
You're
money.
confusing me.
It's either about money or it's about how many. It can't be about
So X
both.
is gonna be how many?
I'm talking about how many.
X is gonna be how many, right?
There are no numbers. X is about how many. That's it.
So it's 7 times in a row.
No, that was confusing me.
But you yell out 20 things. Eventually I tune you out. Like after you yell out 2 or 3 things, I'm
I
like,
see the answer
yeah.
right like 7 times. Like, I keep saying it to you.
Right.
Yeah, you did a good job. man.
There are no numbers about how many. Sit that up on the shelf, please. So there are no numbers about how many. This is going to be very common, that one of the equation is just x plus y equals a number, if it's in this format. All right, again, nothing makes me more angry when I'm going over exactly what is on a quiz, and I just got people carrying on conversation, because then I got to talk over you, it distracts other people, and then I get a little fired up. So let's knock it off, please. So x plus y equals a number is a very common equation. I would ask myself whenever I'm doing a word problem in this format, like the ax plus by equals c thing, so not y all by itself. Is it possible that I could just do a or x plus y equals some number? And then you got to define, you know, what it depends on what x and y would be defined as. In this, the number of airheads plus the number of honey buns, yeah, that makes sense because that would be the total number of items. So always ask yourself that when it's this kind of format. So now let's get to the 15. What's the 15 about?
Money.
I'd write it in. I don't care if you write it in. And you won't see it ever written on a worksheet like this, but write in a dollar sign if that helps you remember it's about money. What numbers are about money?
11.
1 and
No,
one
11 is absolutely not about money.
honey
You're
bun
just
airheads.
guessing numbers. What was it?
Honey bun airheads.
Well, what numbers are about?
1 and 2.
15.
So the one, I've got a $1 and a $2 number. That's
Oh,
the
it's
numbers
this?
about
No,
money,
it's-
They
right?
got 2 honey buns.
All you got to do is match up. So what is the $1 about?
Airheads.
About airheads, right? Well, which variable is about airheads?
X.
X. So again, I make sure I stay in the equation that's about money. So in the equation that's about money, 1 should go with the airheads. Thank you. What number is about, what money number, what number that's about money is about honey buns?
2.
$2.
2, right?
I get it.
So that better go with the variable that's about honey buns, which is the y. I'll tell you that in the problem. Those are your equations. So again, We did that one a long, long time ago, but I talk about it all the time, but now we've officially gone back to it. I got a lot to cover in the next 30 minutes, so you may have to go back and do some review. We spent more time on that than I meant to, but. So we already did graphing, so now we're going to get into solving systems of equations. So this was just creating the equations. Oh crap, no, I'm doing this one super fast. Boy, every time I see this problem, it makes me angry. We did a problem just like this 3 times in class. This was one of them, and that was one of them, 1 and 2. I had maybe 10 or 11 people get this right on the quiz. This is how easy it is. What does sum mean? It means adding, right? What does difference mean? Subtraction, right? I need 2 numbers that add up to 12. Right, because it says their sum is 12. And we just said sum is, well, no, I don't know the numbers. If I don't know the numbers, then that means they're variables, right?
The difference is 4.
There you go, that's one equation. I need 2 numbers, same 2 numbers. If I subtract them, they're 4. There you go. That was how easy that was. 10, maybe 10 people got it right.
Wait.
That's done. How do you
That's it. He's probably trying to combine them somehow.
Because I minus 4 and then that equals 8.
Well, yeah, but we're not doing that. I mean, you could when you went to solve them out. Now that we know how to do elimination, you could solve it that way if you remember, but you wouldn't subtract them. You'd be adding them together. So if you remember our solving by systems of by elimination, we could add these together, right? Because I have the same number in front of the y in opposite signs. So I would get 2x equals 16, so one of the numbers is 8. What's the other number?
8.
There you go. So that one you could actually solve using the new way we learned to solve. And then the bottom problem, same exact thing. 2 numbers add up to 13. X plus y is 13. 2 numbers add up, or I'm sorry, their difference is 3. X subtract y is 3. Like 10 people got that right. And we did that 3 times, and it's all you had to do was change numbers. Literally, you could have gone to your notes and said, oh, there, that's the answer. There, just erase those 2 things and put in the 2 new numbers.
What do you believe
10 people got it right, out of like 100.
Wow.
This is for this problem. Now I did this one then.
Oh, you didn't solve it?
Oh, no, I just solved it a second ago. 8 and 4, we should do. Well, let's solve that one out. Remember, we know that we can solve by elimination, right?
10 minus 3.
10 and 3?
Yeah.
10 minus 3.
No.
10 minus
10 subtract 3 is not 3. Their difference has to be 3. Solve it out, use elimination. Same number, opposite sign. What can you do?
Add.
Can combine them, right? We can add straight down.
16.
So what's x?
2. Wait, no. 8.
So what's y?
8.
Now if you know one of them, you should be able to figure the other one pretty easy. They got to add up to 13. Their sum is 13. We know x is 8, right? Because I divide by 2, divide by 2.
It's 6.
So if x is 8, what does y have to be? It'd be 13. That'd be 14. 5. And isn't the difference of that 8 and 5 3?
Yeah.
There you go. All right, so we need to do some substitution. We already did graphing. We already did graphing.
How much time?
There's hopefully enough time for you to learn how to get a good grade.
Ooh.
I'm worried about that. All right, so here's an easy one on the quiz right here, because I don't even make you solve anything. You have to do the first step, and that's it. I tell you, and this is just like on the quiz, I tell you, do the first step of solving the system of equation by substitution. Well, I know y is equal to everything on this side of the equal sign. So basically everything in that box. Same thing as y. I could write up here. That's what y is. Everything in that box is the same exact thing as y. So the first step of substitution then is just to come down here and say, okay, well, if I know y is everything in that box, I just need to rewrite the other equation. And I need to take the y out. So I got to the point where I'm at the y now in the bottom equation. But I don't want y. I want to get rid of that. And I want to replace it with everything that's in that green box, because that's the same thing as y. This whole expression is the same exact thing as saying y. So I just write that whole thing. And then I just finish it off with equals 73. Don't forget that. That's it. That's all you gotta do. Plug in the correct thing in the correct spot. I didn't even make you solve it out. So there'd be a lot of math. So we did that a while back when we did substitution. We did a worksheet where some of them I just made you do just that. You just had to do the first step. Actually, that was on the last quiz, I think, too. I think we did, yeah, we did an exit takeover, that was on there. So now we do have, there are some that you have to solve out using substitution. So here they are. So in the first problem, easy substitution problem. If I know y, and all of these are the same concept. I can put a box around what's on the other side, because that's the same thing as y. What's in that green box is just like saying y. Same thing, because y equals what's in that green box. So -6 and y are the same exact thing. Well, that means if I go to this equation, I can get rid of that y. So that y right there, I can say, well, I don't need that anymore because I know it's the same thing as -6. And I can rewrite the equation in that. That's an equal sign over here. Not a very good one. Now I can solve. Because I have one variable, one equation, that is something I can solve. 3x plus 36. Make sure you get your positive and negative rules down when you're adding, subtracting, multiplying, dividing. Now that is so there are some two-step equations, by the way, on there. 3 of them. So I'm going to do this as an example of the two-step equation. So when you have a two-step equation, your first step, we focus on the side where the variable is. Your first step, and we want to get rid of the numbers here, because eventually we just want it to be x, and we want all the numbers to be on the right. So that means we got to get rid of all the numbers on the left. That's what you do in every equation, but especially a two-step equation. So to get rid of a 36, I don't divide until the end. So I have to either add or add or subtract. I need to do the opposite. Because remember, when we did elimination, we said same number, opposite sign. Well, we want the same thing to get rid of it. Same number, opposite sign. Very similar to elimination, actually. So now, though, if I do it on that side, I have to do it on that side. Mr. Gill's #1 rule. If you do it on one side, you got to do it on the other side.
Yes.
And now I have I have the last step, basically. Two-step equation, I'm on the last step. Last step is division, divide by 3, divide by 3. X is -2. I do not have to solve for y in this because they already told me what y was. They said, well, yeah, y is -6. We gave you that right up front. So in this one, we didn't have to solve for the other variable because we already knew what the other variable was. Every other problem, if you don't know what the variable is, the other variable, you got to go back and solve for it, like the next one. So on the next one, it's the same process. Everything that I'm doing right now is all substitution. The math gets a little harder, but same process. I write a box around this. What's in that green box is the same thing as saying x. X is the same thing as 2y. I could use either one, doesn't matter. All right, well then when I go to the other equation and I see x, I don't need x anymore. So I have the 8, but I don't want that x. I want to replace it with what's in that box. Now this is 8 times x, so I'm going to say 8 times 2y, and then I just write the rest of the equation. There. I don't change anything else. Once I replace the x, I don't change a single thing. So I do need to remember how to do the math. So I do multiplication first, order of operations. 8 times 2 is 16. I still have that times y though. Gotta include the y, don't get rid of the variable. Subtract 6y equals 30. Now in this one, this is different. I guarantee you somebody in here would do this.
Oh God, the +6.
They do plus 6y. You do that. That doesn't do us any good. All you did is you took variables and you moved them to this side. We don't move variables to the right. If we have variables on the right already, we want to get rid of them over here and move them to the left. But we don't. We only have variables on one side. We don't want to just move them back and forth. We need to combine these. We would just say, okay, well, if I see I have 16 yo-yos, remember, Y stands for yo-yo. I have 16 yo-yos, and somebody takes 6 yo-yos away from me. How many yo-yos do I have left?
10.
So I got 10 Y, 10 yo-yos.
What kind of person is that?
It's 3.
He's a collector of those yo-yos.
Oh, yeah, true. I want to be yo-yo.
Or maybe he
master.
sells yo-yos. Maybe he has 16 yo-yos for sale, and he sells 6 of them. So now we do the last step, which is divide, and we get y equals 3. But we are not done. We don't know what x is.
X equals 8, man.
Gentlemen, this way. Shouldn't hear it during a review.
8.1.
So if I know y is 3, again, I need to go back to one of the equations. I would use the simplest equation, which in this case would be that one, I would say. So if I know y is 3, kind of doing the same thing I did a second ago, only with a number again. Well, if I know y is 3, then I could say x equals 2 times 3. I just replaced this y with that 3, because that's what y equals is 3. So that is 3. So x then is 6. Y is 3, x is 6.
That's cool.
Take down.
Well, I'm not real concerned about that during a review for a quiz.
Yes, sir.
So you can leave it up with me when you leave, and I'll see if I can fix it. Otherwise, we're going to trash it. All right. So this is the this is the last type of substitution you have to actually solve out. So same exact process. I put a box around that because that's what y equals. Notice I've done the same thing. It gets boring, but for some reason we sometimes still don't catch on. That is y. Everything in that box is the same thing as saying y. All right, well, if all of this is the same thing as y, I can get rid of that y right there and replace it with everything in that box. So I'm going to do that. I don't change anything over here. So I get that. That's my new equation. Now there's one sort of like this on the quiz, so I'm going to work this one all the way out. I'm going to do a harder one in a minute because there is one equation that's a harder equation. So I need to get, again, all the variables should be on the left, all the numbers should be on the right. But the way I want you to think about it is I don't want any variables on the right. I do not want variables on the right, and I have them right there. I don't want them there. I want to get rid of those. So I need to do the opposite. That's the opposite. Again, I would never multiply or divide at the beginning of this kind of problem, or in the middle of this kind of problem. I only divide at the end. So I add because it'll never happen. It's not a personal preference, just mathematically we would never wind up there. So if I do it on that side though, I need to do it on this side, and make sure you keep the variables underneath each other. Like don't put the 2x under the 13. Some people do that. And then you try to somehow combine 13 and 2x, which you can't do. Can't combine a number and a term with an x in it, or a variable. Well, you can, but it might be a little disappointing when you get your test grade. So 3x plus 2x is 5x. Think of them as physical things. I'm sorry, but the only word I know that starts with x is xylophone. So if you have 3 xylophones and you add 2 xylophones to it, you have 5 xylophones. Does anybody know what a xylophone is?
Yeah.
How could you not?
I don't know.
Oh.
So, if you have
that's
3 of
what
them and you add 2 more to them, then you get 5 of
Use
them.
X, right?
I thought it was the thing that Squidward uses.
That's a
That's
saxophone.
Yeah, I know.
No, it's
Are
not.
you gonna say a saxophone?
It's not.
Everyone, calm down.
All right, we're not arguing about SpongeBob. All right, that is now a 2-step equation. Again, you have a few 2-step equations. I gotta be honest, I don't remember if they're easier or hard. I mean, they're all easy, I think. But
Yeah, they're all.
you just do the opposite math. You need to get rid of the 5 and the 13. Please refocus. We need to get rid of the 13 first. Do not get rid of the number that is next to the variable until the very last thing you do. So I get rid of the 13. Now, well, if I'm getting rid of that over there, I got to get rid of it over here. Now my last step, I can do the division. So x is -7. I am not done. I don't have y yet. I don't know what y equals. So if I know that's x, I go to either of the equations. I'm going to go to the top equation because it's all positive numbers, although I got a negative there.
Top one's not one.
I'm about to lose it on you. All of you. I don't even know who it is. I know it's you two up front. I don't know how tall Fernando is. He's woken up now, so I don't know. But during a review is a bad time to be doing this, gentlemen. Bad time to be doing it during a review. One thing during a lesson, it's a totally different thing when I have to stop a review that some people care about. And I'll just tell you right now, when I look at your papers, they better be real good. So, so y equals 3 times x, but I know what x is, -7, and then still plus the 13. Nothing changes there. Y equals -21, 3 times -7 plus 13. Y equals -8. Any questions on that? There's a lot of math on this one, like I said. So as soon as that tardy bell rings, I'm going to hand the test out. There's no review, there's no bell work. You're going to need an hour and a half on it. As you can see, you got to work out a lot of stuff to get both answers. We're not done though. We're not done. Yep, it'll be open note. All right, so now we're on to the thing we just learned, but we were struggling
You can
with.
watch the video, just.
I mean, it's constant. It's just non-stop, and I can't deal with it for a whole lot longer. Only reason I haven't done more today is because I don't want to stop the review. All right, so now we're on to solving by elimination. We solved by graphing, we solved by substitution. Now we're solving by elimination the way we've done recently, but I still want to go through a few problems. What's our goal when we solve by elimination? If you don't have this written down, you better write it down on your notes today. You should have written it down if you're here. What's our goal? So I'm going to tell you on the quiz, solve by elimination, so you won't even have to figure it out. But when you see that, when you see solve by elimination, what is your goal? Say it again. We need the same number in front of one of the variables, but then what else also? Same number?
Different number.
No. Can't be same number and different number. Opposite sign. So in this case, we have that.
She said it.
Wait. Frankie said it first.
Again, sometimes I hear it and I just want more people to say it, the more, because, you know, they may not hear what Frankie says on this side, so hopefully somebody on this side also says it. So, same number, opposite sign. As soon as I achieve that, that's when you add vertically. If you haven't gotten to that point yet, don't add vertically yet. It's not going to do any good. So now that I have that, which in this case it was just already set up like that, I add vertically. You already have this in your notes, so if you want to try to find it, it's up to you. If you think it's easier to just make sure you have another copy of it. This cancels out. That's the whole goal, is to get one variable to just go away. And it does. It goes away. So now I just saw what I have left. I combined those two equations. I added them together. I just combined the new equation I have. I'm sorry, I just solved the new equation.
Wait, how did you?
Go, I'm listening.
Because the X's cancel out.
Okay.
Yeah, the X's were already set up to cancel out in this problem. If they have the same number and opposite signs, they'll cancel out.
Okay.
Just like when we solve a two-step equation, we add the opposite, or yeah, add the opposite. So y equals 8. I am not done. In all of the elimination problems, you're gonna have to solve for both variables, I believe. So now I need to pick one of the equations. I'm going to pick the top one because, again, it's all positive numbers, and I like all positive numbers if I can. So here's the equation. That's the top equation. I know y is 8. So again, now it's kind of just like substitution. If y is 8, I can go to this equation and say, well, I don't need the y anymore. I'm going to replace that with 8. And then the rest of the equation is the exact same. I have 3x and 3x plus 2 equals 10 equals 10. All I did is take the y out and replace it with 8. And it's multiplication because this is 2 times y, so this is 2 times 8. 3x plus 16 equals 10. So again, just like elimination, you guys are right behind me. But you're participating, so I don't get on you. So, just like elimination, when we need the same number opposite sign, that's what we're doing right here. We want to get rid of the 16, so we want it to be the same number opposite sign. That's why we do that step, so it cancels out.
Put in a second or
Are you saying when you solve for
See?
this?
Yeah.
No, 2 times
for
8.
the 8. Got this 2 and this.
Well, no, I'm taking the top equation, 3x plus 2y is 10. You could have used the bottom one. You could have used that one if you wanted. I just chose the top one.
Okay.
So now if I subtract 16 there, subtract 16 there, I get 3x equals 6. So if I divide both sides by 3,
You get 2.
negative 2 technically. So my x is negative 2 then. So you do have to do both variables in most of the problems.
So I do the
I
second
should know
variable
yours.
that we get.
I know.
10 minutes.
So that's one that was already set up to work out. I'm going to kind of skip the next version. Oh, wait a minute. Oh yeah, here we go. I'm going to skip this one, but what would we need to do on that one? Do we have the same number in front of one of the variables?
Yes. One of them needs to be a
Do we have
negative.
opposite signs?
No.
So we need to take one of the equations and just change every sign. So I could take this equation on the bottom and say negative x subtract y equals negative 7. And then I don't need that equation anymore. I get rid of that one because I use the new one I created. So if you have the same number but you don't have opposite signs, you just need to flip this every single sign in one of the equations. Don't do that in both equations, just one of the equations. Because you want them to cancel out, and now they will cancel out. Positive 1 and negative 1 will cancel out. That's the worksheet that you had to do. Well, you've already gotten grades for that. Some days, remember, I just give you a grade after you leave, or if I've been walking around and watching what you're doing, later I'll just give you a grade for it. All right, so here's the next kind of problem. Do we have the same number in front of one of the variables? We don't even have the same number this time. There's not even the same number in front of one of the variables. So your next question is, and remember our goal is what? Same number and opposite signs. Is there a number you can think of that I could multiply times 2 to get to 5?
Yes. Yes.
2 times 6 is 5.
No. One, no.
No, there's nothing I can, well, we can't add. It's got to be multiplied. You can't add. And actually, there's not a number you can add to 2x to get to 5x. Because remember, it's technically 2x. Is there a number I can multiply times 1 to get to 3?
Yes, so.
Yeah. Well, no, 1 times 1 is 1.
3, no, it's 3.
I need to multiply something times 1, not something times
1
3.
times 3.
So I could multiply 3 times the 1 and get to the 3. So that's what I'm going to do. I need to multiply 3 times this 1 so that these numbers match up. But I cannot just pick one single number out of the equation and multiply just that number by 3. Whatever I do to one side, I got to do to the other side, which is basically whatever I do to one term, I got to do to every term. So if I'm going to multiply this by 3, I got to get through this, bud. Unless you got like a life-threatening thing going on. Because I got 5 minutes to finish this.
Oh, no, it's
No, not about the calculator. Don't bring anything up about the
no,
calculator.
no,
here.
no, I'm just saying like the answer is, the answer for the -1 times 3 is -3.
Well, we're not even doing the negative part yet. So, if I'm taking that 3, again, I know I need to multiply this 1 times 3 to get a 3, which is what I need. I got to multiply everything by 3 then. If I do it once to one number, I got to do it to every number. So I get -6, subtract 3y, and then over here, 15x. Now, do I have the same number in front of one of the variables?
No, yeah.
Yeah, I got a 3 in front of the y, right? Do I have opposite signs?
Yeah.
Yes.
Yes, if I didn't, what would I need to do?
Make them opposite.
I would need to just flip all the signs of one equation. So if I didn't have the same sign in front of this, or I'm sorry, opposite signs where the 3 is, I would need to flip the sign, just like we did a second ago. All right, so last, I'm not even going to do that one because we're running out of time. Boy, we did not get through as much as I expected. Which is really a shame because I know some people were being very quiet and listening and some were not. It really bothers me. All right, look at number 18. Do I have the same number in front of one of the variables? And again, this is recorded if you can't see in the back. I do not. I have a 5 and a 3 in front of the x. And I have a 4 and a 9. I'm not worried about the negative sign. A 4 and a 9 in front of the y. So if you don't, and is there any number I can multiply times 3 to get to 5?
No.
Is there a number I can multiply times 4 to get to 9?
No.
No, not really. I mean, technically there's always a number, but it's a decimal. It has to be an integer.
Yeah.
So here's the last thing you need to know how to do. And I'll tell you one thing I don't know if I mentioned the other day. This actually works for every type of problem. It's actually the way Mariana's doing it after watching the video. So I could take, and you want to focus on the variable that has the smallest coefficient. Just because it's going to keep your number small is all it is. It'll work with either of them. I want to take the 5 and the 3 and use those just because they're smaller than 4 and 9. I'm going to take the top equation and multiply it by this bottom number, the 3. So every number up here gets multiplied times 3. Every number. Both sides of the equation. I'm going to take the bottom equation and I'm going to multiply it times 5. So again, we took this 5 and multiplied it times everything in the bottom equation. We took this 3 and multiplied it times everything in the top equation. That's not 0.3, that's times 3, times 3, times 3. If I do the math on that, I better get the same number with this variable x. Wherever I chose the numbers, I better get the same number in front of it. I get 15x plus 12y equals -90. Then I get, again, 15x, subtract 45y equals, and again, -90. Do I have the same number in front of one of the variables
Yes,
now?
X.
You better have the same number. That's the whole reason we did the step the way we just did it. It will automatically give you the same number. Again, this will actually work for every problem. So if you don't get how to do that other one where you had to figure out, is there a number that I can multiply times this number to get the other number? This will work if you just do it this way every time. You can always do that. Just take one of the numbers, multiply it times the bottom equation. All right, we're not done. Take one of the numbers, multiply it times the bottom equation. Take the other number, multiply it times the top equation. It will always give you numbers that will match up. Now, though, you still have to do the change the sign thing. So on one of those equations, you got to flip every sign. So you could do this one and say negative 15x plus 40. I'm still going. Please be quiet. I'm recording for a reason. You're already up there, so there won't be any phones for this class after the quiz. So bring something to do on your own. Today was your day to get off of it before you might have some free time. It didn't happen. So that one goes away. Now you have the same number, opposite sides. All right, so that's recorded. I know we went fast. I'm not sure why we didn't get through more. Probably because I had to stop every 5 seconds. But make sure you're here on time. Being late, being tardy is not an excuse for getting more time. Tardy is not an excused lateness. All right, study. Watch the videos. Yeah, exactly. It's like a foreign concept when you study for a quiz. Can't even imagine not studying for a test when I was in school. Can't even imagine. I'm just thinking, oh, I'm not going to study. Big test coming up, I won't study. Different times. So as far as that makeup and as far as that makeup goes, we'll talk after the quiz about what you need to do, but you don't want to just come in and just take it.
Can I press it?
Yeah. You need to watch some videos, and I can tell you which videos.
Oh, wait, why is it writing?
Oh, because I don't have the marker on there whenever the marker's not on there. So now you're going to have to delete so you got to delete, hit the little trash can, and then hit the other little black mark, and then go, there you go. Now it should